Having done the conversion from decimal number to binary numbers, we want to do the reverse, that is binary numbers to decimal numbers. So to do this, we just need to observe that for a base R, and base R is our radix, in which case we call it base. For base 10, we call it as it is radix 10, and base 2, we call it to base 2 or radix 2. So for radix R or base R, if it has two symbols, then the position weight of the end position, we might have position 1, 2, 3, blah 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 blah, all the way up to n of a given number. The weight is represented by r to power n. So for r is n, for r is 2, then we are going to say the positional weight at this point is 2 to power n. N is at this point is equals to 2, so 2 to power 2. If n here is equals to 10, we're going to say 2 to power 10. That's a general rule that allows us to get the positional weight or to convert the binary numbers to decimal numbers. So we are going to start with this example, and this example says that we want to obtain the decimal equivalent of this number. It has two sections or two fractions. This is the fractional part, and this is the whole number. And remember that this is the whole number in decimal notation. So for us to be able to obtain the decimal number that is represented by this binary number, we just need to know the positional weight of each of these symbols, and we have already done it. This is the 0th symbol, this is the first symbol, the second symbol, and the third symbol. So as we have seen that the value is given by r to power n, and we have seen that our r is 2, therefore the value that is represented by the third position is simply 2 to power 3, which is equivalent to 8. The 0, when you multiply by whatever value, it will always be 0, so we'll not look at that. Then 2 to power 1 is equals to 2, and 1 to power 0 is always equals to, or rather 2 to power 0 is always equals to 1. And therefore, this binary number has the value of 8 plus 2 plus 1, which is equivalent to 11 in base 10. Similarly, to get the value that is represented by the fractional number, we just know that the weight of this position is 2 to power minus 1. This is minus 1, this one is minus 2, that is minus 3, and therefore this is equals to 1 over 2, which is equals to 0.5. The next one is 2 to power minus 2 is equivalent to 1 over 4, and 1 over 4 is equivalent to 0.25. So for us to get the fractional value in decimal form represented by this number, which is in binary form, is simply adding these two values, this one, and we get that to be equivalent to 0.75, and we found this to be 11. So this is talking about 11 plus in the decimal, which is to base 10, is also to base 10. Therefore, you add these two numbers, it becomes 11.75. That is the value that is represented by this binary number. So we look at another example that says that convert the binary sequence 0110101.01 to its decimal equivalent. And we follow the same example like we have done. We just give the positional weights of these binary numbers. This is 0, 1, 2, 3, 4, 5, and 6. The ones that are 0, they don't have any value. So we will just start with the ones that have values. We have 2 to power 5. Power 5 is equals to that 2. 2 to power 4 is 16. 2 to power 2 is 4. 2 to power 1 is 2, and 2 to power 0 is 1. So, and then the fractional part, we know that the first fractional number or position is 2 to power minus 1, equivalent to 0.5, and the second fractional number is 2 to power minus 2, is 0.75, and therefore the final number that we get is the sum of this to represent the whole numbers, all these, and the sum of these to represent the fractional part. And this is this is supposed to be 0.25, that you get 0.75. That is the fractional part. When you add this up, it becomes 52, 54, 55. So this is going to 55 plus 0.75. The final number should be 55.75. which is now in decimal. This is the one that is represented by this fraction.